Hello and welcome to this week's Retrieval Market Demo Day. Today's date is Wednesday, the 2nd of February. Today we have Colin from Magmo speaking about Filecoin payment channels and the work they've been doing. And then we have William from Ken Labs speaking about IPFS computing. If you have any questions, please add them to the thread that I'm about to make in Filecoin. And yeah, over to you, Colin.
Okay, yeah, thank you. Let me just get my share going here. Am I up?
Yes.
Okay, so yeah, I'm Colin Kennedy. I'm at Colin Kennedy in the Filecoin Slack. So feel free to reach out if you have anything to say or ask. I'm part of the Magmo team. We're at magmo.com. We have a dev grant from the Filecoin Foundation to do an upgrade on, or to spec out some upgrade work on Filecoin's payment channels. And the work that we're doing can be found at github.com/statechannels/go-nitro. So for the next little bit, I'm going to talk about how payment channels currently work in Filecoin as I understand it. Small caveat here, I'm not a real expert on the Filecoin ecosystem. So my understanding of the Filecoin ecosystem in general is a little bit cursory, but I'm learning more and more. But wherever it seems appropriate, people can definitely throw information at me in the chat or links. Happy to have them. So I'll introduce virtual channels, then go into a little more detail about opening, running, and closing the virtual channel. Talk a little bit about virtual channel networks, and then wrap it all up. Try and say what it might mean for the Filecoin retrieval market and for users and for developers, and then just share a few links. Andrew, another member of the Magmo team, is in the chat. So if you have any questions, feel free to throw them in there. And he knows all of this stuff better than me. So yeah, go for that if there are questions. So payment channels, the kind of base problem is that the trustless delivery of a streaming service requires streaming payments. And this is not feasible on chain because on-chain interactions are not very fast and they are very expensive. They would dwarf the cost of micropayments. So to solve this, the sort of original payment channels notion is that you lock up a bunch of funds on chain and exchange a streaming service for cryptographic guarantees of incrementally redeemable funds. The service provider gets guarantees that they can apply to the chain, that they can recoup funds for services rendered. And this works pretty well. It allows for fast updates and cheap payments. But some limitations are that the time to the first payment is on the order of the block time of whatever chain is underlying the transactions. And the cost per each individual serviced agreement is still on the order of a chain transaction, or probably a few chain transactions in terms of setting up a channel and then later tearing it down, which, you know, varies from chain to chain and over time based on just kind of like gas prices, etc. So an improvement on direct payment channels is virtual channels. And the basic premise here is to move up a level of abstraction. In a payment channel, the channels are funded by on-chain lockups of capital. But in a virtual channel, the funding comes from lockups inside of other state channels. And the promise of a virtual channel, payment channel, is lower latency because your funding agreements are handled by in-channel operations, which operate at network speed, as opposed to a blockchain transaction, and lower costs for the same reasons. It's much cheaper to communicate over the network. and do client-side cryptography than to do a blockchain transaction. And the basic infrastructure for a virtual channel and a virtual channel network is generalized state channels. So in the Filecoin payment channels, what you have is basically sort of the naive payment channel where vouchers are exchanged for, well, vouchers are signed by one party and sent to the other party. And there's not a lot of room for sort of a state channel is different insofar as it allows for arbitrary application state, which allows for us to program something called a ledger channel, which is a specialized kind of channel meant for providing funding toward other channels. So I'll talk, let's talk through the sort of life cycle of a virtual channel, how to make one from another channel. So any channel, before being useful to its participants, has to be funded. So in this diagram, the outer circle is represents the underlying blockchain, and the little dots represent channels. And here we have a channel between Alice and Irene and a channel between Bob and Irene. These channels are funded by direct deposits on the blockchain, the same way that a Filecoin payment channel is funded today. Alice and Bob are sort of the main characters in every cryptography. Irene is labeled with an I because she is an intermediary in the interaction between Alice and Bob. So Alice and Bob each have a funded channel with Irene. They've made their deposits on the blockchain. So the next part of creating a virtual channel is that Alice, Bob, and Irene collaborate over the network to create a three-party channel. This is an unfunded channel, and it only exists sort of on the client machines of Alice, Irene, and Bob. They're then able to virtually fund this channel by applying specific updates to each of their respective ledger channels. So the Alice Irene ledger channel is updated with a specific data structure we call a guarantee, which points to this new channel, and likewise for the Irene Bob channel. Now this channel, which still only exists kind of in the client machines of Irene, Alice.
Again. There we go. We're live again.
Okay, I will try and jump back in there. Yeah, this is my presentation still on screen.
Yeah.
Okay, so yeah, we've just funded the channel using our two ledger channels, and the channel has now become virtually funded. Still only it exists on the client machines, hasn't touched the chain, so it's very cheap. But now that it is virtually funded, Alice and Bob can exchange payments without involving Irene. And this is an important point. Previous payment network constructions that used kind of an HDLC model, which, and I stand to be corrected on this, but I think that includes like the Lightning Network. Those payments involved the intermediaries on every payment. So after this virtual channel is created, Alice and Bob can update that channel with Alice's payments to Bob's as often as they want, and it doesn't involve Irene. This doesn't make a huge difference for Alice and Bob, but for Irene, who wants to act as a hub in a network, it's really kind of a game changer because it allows her to only be involved in the setup and the teardown of the channel rather than being involved in every payment, which makes it feasible to service many more virtual channels when you are a hub. So yeah, in this running channel, Alice and Bob exchange cryptographic guarantees on the state of the virtual channel. They are not capable of updating Irene's balance in the channel. And they interact basically at this point as they would in a traditional payment channel. When Alice and Bob are done, in the Filecoin case, Alice has received her file to completion. Bob has received all of his payment. Then they defund the channel by taking their signed final state of the channel back to their ledger channels with Irene. And Irene, they collaborate with Irene to update that channel, and everything is sort of rebalanced. So here we have Alice has sent a coin to Bob, and in the interaction of this channel. And as that settles, the Alice Irene channel, Irene gains one, Alice loses one, so that represents Alice's payment of one to Bob. Her ledger channel balance is deducted by one. Bob's ledger channel balance increases by one. In practice, these would be probably slightly more in favor of Irene because she's extracting a service fee, but in principle, that's how they open, close, and work. So I'll switch off now and talk a little bit about the sort of network topography, that topology that we expect. So for a service like Filecoin, we don't expect the entire network to necessarily be serviced by a single hub. This is a little visualization tool that I put together that shows clients on one side. Someone can answer. Is my mouse visible on this, or am I pointing
Yes,
at
it
nothing?
is.
It is? Okay.
Yeah, we can see your mouse.
Okay, so clients are on one side, providers are on the other. Hubs are here in the middle, and this here big circle represents the chain. So what's happening here is that these lines from left to right are different virtual channels being spun up. It's probably not easy to see on the shared video, but all of these, the faint lines here between each client and a hub represents a ledger channel. So in order to create these virtual channels, the ledger channels each endure like a single transaction. This opens up a virtual channel, and as the virtual channel comes to a close, the same ledger channels update. So something that wasn't talked about in the slides on spinning up a virtual channel is that virtual channels can be initialized through more than one intermediary, and that is what's going on here. So any given client is connected to a certain hub, but that hub might not be connected to the provider whose file you want. These hubs, though, all have ledger channels with each other, and they are able to, through this connection of ledger channels, you can open up a virtual channel with very similar kind of network overhead and the same sort of desirable properties of like low latency to open a virtual channel, and low cost, because again, it's just updates to channels which are done over the network using client-side cryptography. So the last thing I will show, I've mostly just talked about things that are in this document, which I have just added to the Slack. So this is a rundown of our approach to improving the payment channels that exist in Filecoin. It talks about typical user flow. So making an initial deposit to open a ledger channel with some hub. But then after that, you create virtual channels in collaboration with your hub, your provider, and potentially your provider's hub if it's a multi-hub virtual channel. This includes the same diagrams plus something a little little more detailed on the sequence for funding. So the take home for sort of these upgrades to the Filecoin network is that users can expect lower latency on time to first payment and time to file transfer when they are opening a payment channel. And they can expect a lower kind of amortized cost per establishing a file transfer. Whereas previously you would pay 1 block transaction for each file transfer you initiate. Now that cost is 1 block transfer for each time you decide you need to top up your ledger channel, and if you've run out of money to pay for further file transfers. So that's on the user side, but developers can potentially be able to program their own bespoke stateful virtual payment channels. So the virtual channels, in terms of just like the straight retrieval, would very much mimic the existing voucher channels. A client signs vouchers of increasing value in exchange for receiving data. But because these are generalized state channels, you can make a stateful application with whatever rules you might like, which is potentially useful to anyone building on the secondary retrieval markets. And yeah, these should theoretically, and it's a little out of turn for me to say this because it depends longer term on kind of the implementation of the FVM, but all of this should be able to bootstrap onto an existing ledger channel network, so that a ledger channel network that exists will be able to fund stateful applications of any design. So as I said, there's the Notion doc, and the link is in Slack. Our blog has a lot of pretty in-depth articles on state channels, and feel free to reach out to us at the team, either in the Retrieval Market channel or via email or website. And that's it. If there are any questions, we can take them async in the chat or afterwards. But otherwise, that is my presentation.
Great, thanks, Colin.
I'm sorry. Is that okay if I just jump in, Patrick?
Yes, go for it.
I was going to ask, when you point out the bespoke from developers' point of view, that are you talking there about in general for virtual channels? Because in the Filecoin case, is it correct that for most people, if they use the system, there's going to end up being, this will be just sort of, an automatic facility that they either, interface with on the Filecoin protocol side, or they have libraries that they pull and utilize in their implementations?
Yeah, so I think I'm going to cop out to my earlier caveat of not being an expert of the Filecoin system or ecosystem. But for any like Filecoin user, anybody who's like storing a file and retrieving it, they won't notice, like they don't care about the existence of bespoke virtual payment channels. But my estimation is that people who have goals on sort of the secondary retrieval market, or who want to do something different in terms of a payment structure or what have you, can do so. I mean, I don't. That's sort of. It's not a question that I have a good answer for. But I mean, maybe, for instance, we've spoken with some teams building in the secondary retrieval market already, and I don't know that like progress. There's some progress on like people sort of defining their own personalized payment channels.
Yeah, I mean, I think one of the natural questions for somebody is there's, a payment system that's in Filecoin, and what'll be the delta in using that, version to this version. And it is interesting that the intermediaries, I think your diagram was very helpful to kind of show there's this collection of intermediaries in the middle between, the retrieval clients and the retrieval secondary market servers. And so there'll be a larger sort of, who's actually, running those kind of hub intermediary functions, and kind of discovery process of having well-known ability to find people to facilitate the payments that are right for you. If you're, sitting in Australia, you're not going to want your, intermediary potentially to be located, physically, in the UK, because that's just too big of a time difference. You'd rather have somebody closer who has hardware running closer to you.
Mm-hmm.
Cool, thank you.
Nice. Yeah. Any other further questions or clarifications on the Magmo stuff?
I can maybe make one comment about why the notion of a generalized state channel can be very useful. That's relevant to the Filecoin retrieval market. I know that there's ongoing research about, for instance, how do you incentive a retrieval provider to provide the right data at the right time? We can imagine a world where some retrieval providers have a good reputation and they are going to offer a good SLA to uphold that reputation. We can imagine other retrieval providers who want to enter the network and haven't yet developed that reputation. And we can imagine using different payment channel constructs for having a retrieval client interacting with those different classes of providers. For instance, if I generally trust the provider because they have been providing good service empirically to lots of people, then we might operate on what's called a micro trust model, where my client simply sends a little bit of money on some streaming basis as I'm getting the bytes backwards. That's something that the current Filecoin payment channels can do. If you had a direct channel, they can do it pretty well. If you didn't have a channel already with that provider, you either need to create one that uses those on-chain transactions, or you can use this notion of a hash time lock contract, and that creates a lot of network overhead involved in sending a stream of payments. We consider that to be not viable at a production scale. Nevertheless, the current Filecoin payment channels can work if you did have this direct channel open with your provider. What the current Filecoin payment channels cannot do is, as an example, set up a payment scheme where my payment to this new provider is conditional on the provider actually sending the correct bytes that I can verify, for instance, by checking against some encoding of the file in some Merkle tree. I'm not an expert in that type of stuff, but that's the type of interactions that you can do with a generalized state channel network that you can't do with the current technology in the Filecoin network. And those are the kinds of directions that we're pretty excited to explore moving forwards. Right now, we're focused on getting very simple payments working across multiple hops using those intermediaries, but removing the intermediary from the stream of payments. That's what we're focused on today. But in the future, we also want to explore these other ways of incentivizing new providers to behave nicely until they develop the type of reputation that allows us to drop those requirements.
There are even farther out models that I know, Patrick, you mentioned sometimes, so I think it's useful just to put on the recording if somebody's gone through and listened to virtual channels to hear that they're flexible in other ways too. Since it's off channel, what's being recorded and passed around in the tokens can have different meanings. Like, it's also possible that you could have a network where someone is paying for the transfers. Maybe a user has a monthly subscription to a CDN network, or maybe users come in publicly and someone pays, the secondary network to output their data, but they want to know who to actually kind of compensate, who's actually providing them benefits from that. And so in these channels, bespoke, it could actually be, sort of accounting tokens that the secondary retrieval providers are collecting to show that they were, in fact, actually providing data to end users, and in a very transparent, recognizable way, because it has cryptographic signatures when they go to kind of cash in these accounting tokens and show the value they brought to the network. And as a user, the network could potentially look at your tokens, and you could have a balance that if you've exceeded it, the secondary network providers say, oh, you've hit your cap for the month, or what have you. So there's a whole bunch of really interesting economic models, and they're just, I would say, maximal flexibility with state channels. That's the really valuable part while you're getting this full scaling benefit.
Yeah, definitely. I think it's super exciting, the work that's going on. It keeps coming up in more and more conversations around the retrieval markets ecosystem, about where it could be applied in its kind of most obvious context, and then, as you say, in sort of more innovative or thoughtful ways. And we just got to lay out how it's going to integrate with the existing Filecoin stuff, and just make that happen over the next few months. So yeah, really exciting. Thanks very much, guys. Cool. And that takes us to the second presentation. So yeah, William, over to you to speak about IPFS computing.
Thanks, Patrick. Let me share my screen. Okay. So can you see my screen?
Yep.
Yeah, we can.
Okay. Thanks. So the whole team now they're based in China, so it's a Chinese New Year now, so the team are off. So today I'm not going to bring too much to you guys. So we had some research on the IPFS computing, so I'm taking this opportunity to share and give some demo on it. So we name it as IPFS computing. Quickly go through the agenda. So actually 2 topics, introduction and the demo. A quick introduction to this, what we call the mesh, IPFS computing mesh. There are several components in the network. The idea is that we want to have the code deployed to a network so that it can be executed in a decentralized manner. We have executor and a scheduler. Scheduler is responsible for managing the executors in the network. So they are communicated over PubSub. The client typically is a web browser or the web app we develop, or you can build your own. So the client is communicating or making an API call to scheduler to find the executor for it. And the worker, the executor, and the channel information is turned to the client so that the client will know where the executor is and what's the, it's not where, it's the channel or the topic, what the topic he or she need to use to publish the request or send the request. So this is how the components are communicating with each other. And the client will receive as a PubSub response. So it will receive the result of the execution from the network. There are a couple of key points to share. First of all, we support Rust now. So we have the Rust to WebAssembly transformation. And so the WebAssembly will be content addressable as it will be deployed to the network. And the executor scheduling is managed by the scheduler. Eventually, we have the computation result on the network as well. So it's content addressable, which means there will be a CID assigned to the result. So I'm going to quickly give you a demo here. I have a piece of code. So this is a simple page we develop. And if I copy the code here and type the value or the parameter, so the code is to look for the Fibonacci number identified by the value I enter here, or the index. So as I click the execute button here, so the the code is uploaded, and it will be compiled by our component and uploaded to the IPFS network. So the code will eventually identified or addressed by a CID. And the parameter is also passed to the server side, we call the scheduler. It will look for the executor, get it executed. And the result will also be put on the network so that the client is able to subscribe to the result. As you can see here, this is the logic or the data flow. Eventually, we receive the result. So as a Fibonacci numbers, the series, the third one is 112. So that's a 2. We can also slightly change the code. Maybe that's, yeah, this is just for demonstration purpose. So I make some really simple change to the code. For example, if we change the code and say, I want to know the square of the number n, and we can set it to 9, execute. So the code will be uploaded again, deployed to the network. And before it's deployed, so what's deployed is the WebAssembly, the package or the release. So the code will be compiled by the executor. So this is how you can see the result here. So the client or this web browser subscribe to the topic, and the result is ready for collection. So the client can receive the result and show it here. This is a just a concept of IPFS computing. We are looking to get into more practical usage. For example, in some use cases, we say the function can be stateful or stateless. In some is stateless, for example, in stateless cases, we can consider when you pass the same parameter to the same function, the result will always, or the response will always be the same. So that's what we can do and optimize. So in this case, you might see that you don't have to run the code every time. So once you run, the result is on the network. So it's somehow like it's cached. So you can quickly find the result. So you can avoid the further execution. But in terms of the state, we may need to find some way to manage the state on the network. But it's still something we can do to make it more powerful. So this is the idea is to bring the computation power to the IPFS network. That's pretty much it for today. I think this is the demo, and this is the architecture. So if anybody has any question, feel free to ping us on the Slack. We are happy to answer. Thanks. That's a demo for today.
Could you move back to the architecture diagram?
Sure, yeah.
So my mental model is that the code that I want to execute gets compiled to WASM and the package is uploaded and stored in IPFS.
Yeah.
And if I want to execute that code, where does the code get executed? It gets executed on the...
So it's on the executor server or executor side.
Okay. So there would be a network of executor servers who can fetch the code from IPFS and then execute.
Yeah. So the scheduler will let the executor know. So executor know what code need to be executed, and it will do the job and put the result back to the network and notify.
And I think the obvious question that comes to my mind is how can we trust the executor server to perform the correct computation in this case?
Yeah, it's a good question. For now, we haven't designed the such layer to the executor. this is definitely what we need to bring to the whole architecture. So this is to be figured out.
Cool.
Awesome. Yeah. Any other questions or clarifications?
I sort of have a question about the reverse of that, which is what are the protections against someone writing some malicious code and uploading that to the executive server and making something bad happen there?
Yeah, that's true. That's a big question, and one of the biggest risks we need to tackle. But for now, we have no answer to that. We will let you know.
Nice. Yeah. Well, it seems to be some questions generated about the decentralized model of this, but it's really interesting to dive into the IPFS fan stuff because I'd only seen it in its paper form. So great to see some stuff around that. And also happy Chinese New Year.
Thank you very much.
Anything else anyone wants to add before we finish this presentation? Nice.